Water. Water is everywhere on this planet. It is essential for life. It covers 70% of our Earth's surface. Water is everywhere. It's in our atmosphere. It's in the bottled water that we drink every day. It's in our swimming pools. It is so essential for life that we cannot do without it. Most people would know that if we released water from a height with gravitational potential energy down a slope, it would go downhill. But what if I could tell you, water could travel uphill?
Water going uphill? Do you mean like this?
No, I mean the Leidenfrost effect.
Oh, what's that?
To the physics lab! Well, here we are.
E7B, 130.
Second first. Most people are familiar that if you drop water onto a warm plate at sea, it will slowly evaporate.
Wow.
Our resident scientist, Monique, will now explain evaporation to us.
When water touches something above its boiling point, the molecular bonds break and it evaporates into steam.
And at what point is this? What temperature?
100 degrees Celsius. When we heat it up, strange things start to happen.
Wow. Is that levitating?
Sure is, kiddo.
But how?
The bottom layer of the water instantly vaporizes, creating a layer of steam for the rest of the droplet to float on, so that the droplet doesn't hit the hot plate. Steam has a poor thermal conductivity, and this means that it will insulate the bottom of the droplet against the heat, so that it can rest above the hot plate, and thus last a lot longer without evaporating. The resulting layer of steam will be thicker in the middle, at about 0.2 millimeters, whereas the sides of the layer will be thinner, at approximately 0.1 millimeters. The steam is constantly replenished as the rest of the water droplet evaporates very slowly.
But how will this cause it to go uphill?
Well, Alex, this is no ordinary block.
Yes, Morgan, it has special grooves cut into the surface which allows the water and steam to travel in the direction of the downward slanted grooves.
How does that happen?
Well, check this out.
In usual circumstances, water will flow downhill due to Earth's gravitational fields pulling it towards the centre of the Earth. The water will follow the grooves in the block, regardless of if this will make it travel uphill or downhill. The droplet is attracted to the Earth with a force equal to its mass multiplied by the gravitational attraction, so the droplets move upwards. The force due to the heat and the block has to be greater than this. The steam underneath the droplet flows down the grooves of the teeth, and this causes the droplet to move also, as it is brought along with the movements of the steam. This gives it enough momentum to reach the next tooth in the corrugated block, and the process continues.
So Alex, can you help us summarise the Leidenfrost effect?
So basically, when the water droplet hits the grooved surface of the heated block, it is instantly vaporized, and this in turn creates a layer of steam, which then insulates the water droplet from the heat of the block.
And how does this cause it to travel uphill?
The steam that is insulating the water droplet falls into the grooves of the block, and this helps it travel uphill.
Congratulations, mate. I think you've passed.
Branches were so